Dear student, welcome to this session. I am Khalil Ahmed Chikkerur, Maths Paper 2, Vector Calculus and Differential Equation. So in this session, we discuss about differential vector operator, gradient. Gradient, let phi of x, y, z be a defined and possesses first order partial derivative at each point x, y, z of a certain region of space, then the gradient of phi is defined as the vector function I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z and is denoted by grade phi. Note, it is found very convenient to introduce a vector operator called del or nabla, written as del equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Then grade phi, which is equal to I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z, which can be written as in bracket I dou by dou x plus j dou by dou y plus k dou by dou z of phi del phi. So grade phi is equal to del phi. So gradient is called vector operator. First, properties of gradient theorem. If u x y z is a function of x y z and v is a function of v x y z are two scalar point function, then grade of u plus or minus v equal to grade of u plus or minus grade v. Grade of uv is u grade v plus v grade u, and grade of u by v equal to v grade u minus u grade v divided by v square if v is not equal to 0. So example, find gradient of phi which is equal to x square y plus y square x plus z square at 1 1 1. Grade phi is del phi, which is equal to del of x square y plus y square x plus z square, but del equal to summation I dou by dou x of x square y plus y square x plus z square. So I into, so differentiate, so summation I dou by dou x means differentiate partially with respect to x plus with respect to y plus with respect to z. So phi, the given function is differentiate partially with respect to x and with I, next with respect to y and j, with respect to z and k. So I into, so differentiate this with respect to x is 2xy plus y square plus j into x square plus 2xy plus 2zk. Hence at 1 1 1, so x y z is replaced by 1 1 1. So grade phi is 3i plus 3j plus 2k. So next time example, find del phi which is equal to grade phi, gradient phi, and mod of del phi at 103, where phi is xy plus yz plus zx. Solution phi equal to xy plus yz plus zx. Del phi is dou phi by dou x of I plus dou phi by dou y into j plus dou phi by dou z into k. So phi is given if you differentiate partially with respect to x means y plus z into I plus differentiate partially with respect to y is z plus x into j, and with respect to z means x plus y into k. At 103, del phi is equal to 3i plus 4j plus k. So modulus mod value of del phi is square root of coefficient of I j k. So 3 square is 9 plus 4 square is 16 and 1 square is 1. So it is root 26. If r equal to, next example, if r equal to xi plus yj plus zk, then show that grade r equal to unit vector r and del of gradient of 1 by r equal to unit vector divided by r square, which is r square, not x square, r square. Third one is del of r raised to n is n r raised to n minus 2 into r. Solution r is the given vector xi plus yj plus zk. R square is r dot r, which is x square plus y square plus z square. Differentiate r square partially with respect to x means 2r dou r by dou x equal to 2x. This implies dou r by dou x equal to x by r. Similarly, we have dou r by dou y equal to dou y by dou r, comma dou r by dou z equal to z by r. First, grade r. Grade r is dou r by dou xi, dou r by dou yj plus dou r by dou zk. So substitute the values of dou r by dou x, dou r by dou y and dou r by dou z. So dou r by dou x is x by r into I plus y by r into j, z by r into k, which is equal to xi plus yj plus zk divided by r. So xi plus yj plus zk means vector r divided by r. So vector divided by it means it is unit vector r. Second one, del by 1 by r, that is grade of 1 by r. So dou by dou x of 1 by ri plus dou by dou y of, by definition, dou by dou y of 1 by r into j plus dou by dou z into 1 by r into k. So differentiation of 1 by r with respect to x is, so r is also function of x, y, z. So r is also variable. So minus 1 by r square, 1 by r, differentiation of 1 by r is minus 1 by r square dou r by dou x into I minus this plus into minus of this, minus of 1 by r square dou r by dou y into j, which is plus into minus of 1 by r square dou r by dou z into k. So minus 1 by r square if you common, so x by r. So x dou r by dou x is x by r, dou r by dou y is y by r. Substitute values of these values. So minus 1 by r square common. So x by r into I plus y by r into j plus z by r into k. So minus 1 by r square. So if you simplify, it is x I plus yj plus zk divided by r. So minus 1 by r square into, so xi plus yj plus zk means vector r divided by r, which is unit vector, minus 1 by r square into r, that is unit vector. So minus r divided by r square, unit vector. So third one, del of r raised to n is n r raised to n minus 2. So del of r raised to n is dou by dou x of r raised to n into I plus dou by dou r raised to n by dou y j plus dou r raised to n by dou z by k. So dou by dou x of r raised to n is n into r raised to n minus 1 into dou r by dou x plus n into r raised to n minus 1 dou r by dou y into j plus n into r raised to n minus 1 dou r by dou z into k. So taking n r raised to n minus 1 common and substitute the values of dou r by dou x, dou r by dou y and dou r by dou z, which is x by r into I plus y by r into j plus z by r into k. So n into r raised to n minus 1. Simplify, we get xi plus yj plus zk divided by r. So r raised to n minus 1 divided by r is r raised to n minus 2. So n into r raised to n minus 2 into vector r. Prove that del of a dot r equal to a for any constant vector where constant vector a where r is xi plus yj plus zk. So let constant vector let a equal to a1i plus a2j plus a3k, r equal to xi plus yj plus zk. Then a dot r scalar product a dot r is a1x plus a2y plus a3z. So del of a dot r equal to summation I dou by dou x of a1x plus a2y plus a3z. So which is equal to summation of a1i, that is a1i plus a2j plus a2k, which is equal to a. So therefore del of a dot r equal to a. So these are references. Thank you.